Today we're going to talk about factoring four-term polynomials by grouping. Before we do that, we're going to look at some skills review. So at this time, I want you to take a couple minutes to pause the video, and I want you to work through the top part of your notes. So I want you to try each of those problems, A, B, and C, and then factoring special cases and trinomials, 1, 2, 3, and 4. So go ahead and pause the video now and try those 7 problems. All right, so I'm going to give you the answers to these. Check your work and see if you got them all correct. If you didn't, just put a star next to it, and you can ask me about it next class when we're together so that you know how to do it. Factoring is not going away. It's still going to be on your test, your Unit 5 test. It is also going to be again on your Unit 6 test. So we're going to be learning more factoring and more things to do with each of these. So we want to make sure that you know how to do them. All right, for A, we can factor a GCF out. So it says look for the GCF. We're going to factor, we can take an X out of each of those. So we're going to take out an X. Doesn't look like a pretty X. Okay, X. And then what's left when I take an X out of each of those is X plus 5. For B, out of 16 and 12, I can take the greatest common factor of 4. I have 3 X's here and 2 here, so the most I can take out is X squared, and I'm left with 4X minus 3. And C, the biggest number I can take out of 10 and 15 is a 5. I can take out 2x squared out of each of those, or just a x squared, and then I'm left with 2x plus 3. All right, greatest common factors are really important for this next lesson that we're going to be doing, the factor by grouping, and we have to know how to take the GCFs out in order to be able to use this method. Okay, so that was good practice. All right, the next one we're going to look at is a review of factoring trinomials and special cases. Remember, anytime we have to factor a trinomial, the first thing that we look for is there a GCF. Since these are all even numbers, I'm going to assume that I can take out a 2. Okay? Because A is negative, I also have to take out the negative. So I'm going to take out a negative 2 from each of those. And when I do that, I'm left with x squared minus 2x minus 35. I'm not finished yet. I still have to factor the rest of this. So I need 2 factors. It's minus minus, so I know I'm going to have one positive and one negative. I just need to determine which is going to be which. So I need factors of 35. That's going to add up to be negative 2. So I'm going to think maybe 7 and 5 might work. Okay, so x, I'm going to put minus 7 here because this is a negative 2, and x plus 5. If I check my work, I can always see if I'm on the right track. So 5x, negative 7x. Negative 7x plus 5x is negative 2, and that is my correct answer. Remember, I have to write all of it in order for it to be correct. So I must write the negative 2 with the rest of my factors. All right, number 2. Is there a GCF that we can take out of 10, 11, and 8? Nope, because 11 is not an even number, and there's nothing that factors out of it with the rest. So now I have to factor that one separately. I need all the factors of 10, all the factors of 8. So I have 10 and 1, 5 and 2, 8 and 1, 4 and 2. So I need to check each of those to see which ones are going to work. I'm going to write my 2 factors. I know I need 1 plus and 1 minus, so I'm not going to fill those in yet until I figure out which ones are going to get me to where I need to go. All right, if I try 10 and 1 and 8 and 1, that's going to give me too much. It's going to give me 80 and 1, or it's going to give me 10 and 8. That doesn't get me to 11, so that's not going to work. Okay, if I try 5 and 8, 8 times 5 is 40, and 2 times 1 is 2. That gives me 42 or minus, which is going to give me 38. That doesn't work. but let me switch it. Let me try 5 times 1 is 5, and 2 times 8 is 16. 16 minus 5, yep, that gives me 11. So I'm going to try these two here. I'm going to get 5x and 2x. I multiplied my 5 and my 1 together, so this is going to be a 1. And I multiplied my 2 and my 8. All right, and I need a plus 11, so this is going to be plus 8 and minus 1. Let me check it. This gives me negative 5x. This gives me 16x. 16 minus 5 is 11, and that works. So this is my 2 factors. All right, number 3. We have some pretty big numbers here for number 3. And there's not a greatest common factor here because 49 is not an even number. So since there's not a greatest common factor, and these are some pretty big numbers, I'm going to look for the perfect square trinomial. Is 16 a perfect square? Yes, it's 4 times 4. Is 49 a perfect square? Yes, it's 7 times 7. Okay, so I'm going to see if it works. I'm going to put it in. Remember, perfect square trinomials have one factor. Because these are both plus plus, this is going to be plus, and it's going to be squared. So my first one is going to be 4x, and my last one is going to be 7. So 4x plus 7 quantity squared. If I multiply those out, I should get 56 in the middle. So if we just try it, we can see if it works. So 4 times 7 is 28x. 7 times 4 is also 28x. 28 plus 28 is 56x, and yes, it matches. So this is how we write our final answer. 4x plus 7, quantity squared. And the last one, 6 and 54. Is there a common factor? Yes, I can take a 6 out of both of those. So if I take a 6, I'm left with x squared minus 9. Now I still need to look because this is a minus sign. That means that could be the difference of two squares. So x squared, yeah, x times x, 9, yeah, 3 times 3, so those are both perfect squares. So that means I can factor this thing again. So I'm going to keep my 6, and I'm going to factor into 2 factors, one positive, one negative. My x is going to go here in my 3, my x and my 3. And that is my final answer. Okay? This right here is really, really important to remember the difference of two squares. Okay? Because we are going to need it for what we're doing today when we're factoring 4-term polynomials. All right. So let's go down to the bottom, factor by grouping. We're only going to factor by grouping when it's 4 terms, okay? So used to factor polynomials with 3 and 4 terms, we are only going to be doing the 4-term one. We always must make sure that the polynomial is in standard form. Okay, before you get started, we must check, is it in standard form? So if I look at the example below, it says factor the polynomial by grouping. I have to check, is it in standard form? Is the highest exponent first? Yes, it goes 3, 2, 1, and to my constant. So yes, that is in standard form because it goes from highest exponent to lowest exponent. Okay, next thing I'm going to do is I am going to put parentheses around my first set of numbers, x cubed plus 3x squared. And then I'm going to group the second set of numbers together. So plus 2x plus 6. We have to include that plus 2x right there because it's attached to the 2. So it needs to be in the parentheses. Okay, so we're going to group the terms into pairs using parentheses. Okay, then we're going to factor the GCF out of each quantity, okay? So the first quantity is x cubed plus 3x squared. So on this one, I'm going to look for the GCF. I can't take any numbers out of here, but I can take x squared. So I'm going to take an x squared, and I'm going to write it on the outside because it's the GCF. And then I need to write what's left. If I take x squared out of x cubed, I'm going to have an x. Plus, if I take x squared out of 3x squared, I'm going to have a 3. So x squared times the quantity x plus 3. Okay? Now out of the second one, I'm going to look at this one. What can I take out of both of those? I can take out a positive 2. So I'm going to have plus 2. Okay? And then I'm also going to write what's left. I'm going to have x plus 3 left. Now, the biggest thing to recognize is these two should be exactly the same. Your parentheses should have the exact same factors. Those should be the same. So if they're the same, we know we're on the right track. We're going to write it out front. That's the factor that they both have in common is x plus 3. We're only writing it one time. Then I'm going to write what is left out of the other two factors. So I have an x squared left, and I have a plus 2 left. And I'm going to put that together in one parenthesis together. Okay? So my final answer for this is x plus 3 times the quantity x squared plus 2. That is your final answer. Regroup the binomial, both terms share, and the GCFs. Okay? So that's all there is to it. This is actually a little bit easier than factoring trinomials. It's just using the greatest common factors to help you factor by grouping. Okay? All right, so let's go through a couple examples. We're going to look at the first example. I'm going to group these things, so I'm going to group them here, and I'm going to group it here. Make sure I include the negative with the 3. I want to make sure that that's grouped in there. Okay, I'm going to look for the GCF in my first group, which is going to be a 2 and a 4, so I know I can take a 2 out. I have x to the third and x squared, so the most I can take out is x squared. When I write what's left, 2 divided by 2 is just 1. I have 3 x's on top, 2 down that I'm taking out, so I get x. Plus 4 divided by 2 is 2, and x squared divided by x squared is 1. So that one we don't worry about. All right, the next one. Here, I know that 3 is the common factor, but since I have a negative in the front, I always have to take the negative out. So anytime the negative is in front of any of our polynomials, we have to take the negative out. So I'm going to take a negative 3 out. And when I do, I'm going to be left with x. And remember, negative divided by negative gives me a positive 2. So negative 6 divided by negative 3 is positive 2. Now I'm going to look to see, do these two match? If they match, write it out front. We're good. I'm going to write that as my first factor. Okay, x plus 2. Then I'm going to write what's left. So what's left is 2x squared minus 3. Okay, x squared was my GCF. Now I'm going to look at this one. This has a minus sign. Okay, so I'm always going to check for the difference of two squares. Is 2 a perfect square? No, 2 is not a perfect square, so then this one is not the difference of two squares, so I can keep this as my answer. Okay. All right, we're going to look at number 2. And again, if I'm going a little bit fast, you can always pause it and rewind it or redo it so that you can go at your own pace. Okay. All right, make our parentheses. Both factors. Factor out the GCF of the first one. So I have a 2 and a 3. I can't take anything out of there. X to the third and x squared, I can take an x squared out. Then I'm going to write what's left. I have a 2x plus 3. On this one over here, I have a negative up front, 18. So that means I have to take a negative number out. The GCF between 18 and 27 is 9, so I need to take a negative 9 out, and I'm going to be left with negative 18 divided by negative 9 is positive 2x. Negative 27 divided by negative 9 is plus 3. All right? These do match. Since they match, I can write my factor down here only one time, and then I'm going to write what's left. What's left is x squared minus 9. All right, now I need to check again. Since this is a negative, is this the difference of two squares? Okay, is that the difference of two squares? Okay, yes, because x squared is a perfect square, that's x times x, and 9 is a perfect square, it's 3 times 3. So I need to factor this one more time. I'm going to keep my first factor, 2x plus 3. Then I'm going to factor this. Remember, difference of two squares has two factors, one positive, one negative. This one's going to be x plus 3, and this one's going to be x minus 3. And that is my final answer. Okay? So the biggest thing to remember is to make sure we always look for the difference of two squares in these. We learned them for a reason, and this is exactly that reason, because we still have to keep factoring them when we're factoring four-term polynomials. All right, we're going to look at number 3. Okay, for this one, let's group them. So we got them grouped. This is another special case, so this is kind of a different one that we got to really pay attention to. I can't take any numbers out, but I can take an x squared. So I'm going to take x squared out. I'm going to be left with x plus 3. Okay. Over here, I can't take any numbers out. I can't take any variables out. Since I don't have a GCF that I can clearly take out, the only number that can come out is plus 1. Okay, so a 1. I can take a 1 out. When there's nothing else to take out, I have to take out the 1 because I need a number to go here. I've got to have a number to go there, okay, so that it's part of my factor. All right, now that I got this 1 out, okay, I'm going to write what's left. Well, if I take a 1 out of here, it's not going to change. It's still going to be x plus 3. Now I look. Are these the same? Yes, if they are, write it as my common factor, and then write what's left. X squared plus 1, okay? Since this is a plus, I can't factor it anymore because it's not the difference of two squares. It's plus. They are two perfect squares. X squared is x and x, 1 is 1 times 1, but because it's not the difference, it is not factorable anymore. So this is my final answer. Okay, so that one, pay attention to. This one, pay attention to because we have the difference of two squares. Okay, all right, now we're going to go down to a couple on the bottom. So you can try 4, 5, and 6. You can go through those and try them. Okay, I can give you answers. Number 4, I'll give you the answer to that one, is going to be k minus 4, and then k plus 2, and k minus 2. So you can go through and practice those and check and see if your work is correct. So you can pause the video for a couple minutes and work through those and see what you get. All right, number 5, this one, the final answer is going to be 5x squared plus 1. And x minus 8. And again, these are interchangeable. Most of the time, I would have written it as x minus 8 because that's the common factor, and 5x squared plus 1. It doesn't really matter which way you write it as long as both factors are correct, okay? And I wrote that one that way on purpose so that you could see it. Doesn't really matter. I always like to write the GCF one first, the one that's common, and then write what's left as the second one. But it doesn't really matter. All right, number 6, the answer to that one should be x minus 5, x minus 2, and x plus 2. Okay, so work through those and check them out. Okay, all right, so we're going to take a look at the bottom ones. Number 7. We have 2x cubed plus 5x squared. We're going to do these just the way we did before, except we are going to have to solve them now. And remember, we always want to check for the difference of two squares. So 2 and 5, nothing in common. We only have an x squared in common, so we're going to be left with 2x plus 5. We have a negative here, so we must take a negative out. The number that 18 and 45 have in common is going to be your 9. Okay, so minus 9. And then we have 2x, and negative 45 divided by negative 9 is plus 5, equal to 0. Do these match? Yes. So let's write it as our common factor. And then write what's left. X squared minus 9 equal to 0. Is x squared minus 9? Since it's minus, it is the difference of two squares. This is x times x, 3 times 3, and you guys will get used to seeing those. You're going to know exactly which ones are perfect or difference of two squares because we see them so often, and they're your basic ones. So I'm going to keep 2x plus 5. Difference of two squares factors into two factors, one positive, one negative. So we're going to have x plus 3 and x minus 3 equal to 0. Now we have 3 factors. So we have to take each factor and set it equal to 0. And then solve. So no different than what we've been doing before with trinomials to solve. We just have more, sometimes we're going to have more factors. So this one, I'm going to subtract 5 from both sides. I get 2x is equal to negative 5. Divide by 2. I get x equals negative 5 over 2. This one, subtract 3 from both sides. I get x is equal to negative 3. And this one, I'm going to add 3 to both sides. So x is equal to positive 3. And there we have it. We have 3 solutions for factoring this 4-term polynomial. It's not always going to work out with 3 solutions unless you have the difference of two squares. So like if we went up here to this one right here, if we were to solve it, it would only have 2 solutions because it only has 2 factors. Okay? All right, and that is pretty much it. I'm going to give you the answer to number 8, and you can see if you can figure those out. So x is equal to 3/2, x is equal to negative 3/2, and x is equal to 1/2. So see if you can factor those and get to the answers for that. All right, that is all that I have for you today. You can now get your homework and start working on that. Hope you have a great day, and I will see you guys on Friday.